Welcome children, welcome to Refresh Concepts with me Dinesh Modi. Let's move further with the next chapter. The next chapter is what we are going to study is reflection. Now children, in science we have learned the image of an object so formed, right? Reflection is nothing other than on the same lines. Reflection comes under maths, is what we have studied under science, image of an object so formed. So let's take what do you mean by image of an object. So here we are going a bit scientifically. Image of an object in a mirror. When an object is placed in front of a plane mirror, then its image is formed at the same distance behind the mirror as the distance of the object from the mirror. So we all are aware, say for example, that we have an object kept in front of the mirror. There will be the image so formed of the same object, right? It will be forming behind the mirror. But what is the main thing we are supposed to learn and understand? The distance between the mirror and the object will be the same as the distance between the mirror and its image. The distance between the mirror and the object will be the same as that of the distance between the mirror and the image. On the same lines, children, in science is what we study object and its image. Here in maths, we are taking the same thing under the title reflection. So let me elaborate what I want to say. So we have a point P. You can consider, as of now, for a minute you can say AB is a mirror. Now, this is my object. Object is placed in front of the mirror. What am I going to get? I'm going to get its image. So P dash is nothing but my image if I'm talking in terms of science. So how far is the object? The object is at a distance of MP. That is, distance between the object and the mirror is distance MP. Same shall be the distance of the image P dash. So MP dash and MP should be the same. That is what science says. Let's talk now in terms of maths. Now instead of considering AB as a mirror, now I'm taking AB as line of reflection. Now I'm taking AB as line of reflection. And what is my P? P is mere a point. What is my point P? P is mere a point. Now every point will always form its reflection under certain line of reflection. Every point will always form its reflection under the line of reflection. So point P under the line AB, which is line of reflection, will give me reflection of the same point P in terms of P dash. What we need to understand, the distance of point P from M, that is from the point of line of reflection, distance perpendicular mind you. So M to P and M to P dash will be the same as we do it in science. Right children? Right. We proceed further in order to understand this one more in context to our chapter. What we have done is we have taken a coordinate axis. I hope my children are very much aware about coordinate axis. X-axis, Y-axis are termed as coordinate axis. Now I have told this in my earlier videos, in earlier chapter, equation of line. Equation of x-axis is nothing but y equals to 0 and that of y-axis is x equals to 0. Now why we need to learn? Because many a times now, many boards, instead of saying reflection along x-axis, they might say y equal to 0. Instead of saying reflection along y-axis, they might say reflection along x equals to 0. So we should know, if they say y equals to 0, that means they are trying to say x-axis, and if they say x equals to 0, they are trying to say y-axis. Please keep this in mind. Coming back, so what we have our coordinate axis. Now what we have taken is, we have taken one point P, whose coordinate is 3, 2. So 3 is the x coordinate, 2 is the y coordinate of that particular point. We have a coordinate axis, we have taken first point P, 3, 2. 3 is the x coordinate, 2 being the y coordinate. X coordinate is also termed as abscissa and y coordinate is also termed as ordinate. I hope you are aware. If not, please take this. X coordinate is also termed as abscissa, y coordinate is also termed as ordinate. So my abscissa is 3 for point P and my ordinate is 2 for point P. Now what we are going to learn is, we are going to learn reflection of this particular point whose coordinates are known to us along different lines of reflection. I repeat, what we are going to learn? We are going to learn reflection of this particular point along different lines. So what we do is, we first take this particular point and in the very first instance we are taking the line of reflection is x-axis. We are taking the line of reflection as x-axis. Either you say x-axis or you say y equals to 0. So either you say x-axis or you say y equals to 0. Now reflection of point P, whose coordinates are 3, 2, when I reflect this particular point, or rather when I take the reflection of this particular point, will it give me P dash? You can take the same example. You can take it the same thing happening here. So the reflection of point P will be P dash. Everything written over here, but when I try to get the coordinates of point P dash, I shall get as 3, minus 2. Mind you, again here, the distance between the point on the line of reflection to the original point and its reflection should be the same. So if I have to say that this is my point O, or sorry, this is my point L, then LP and LP dash will be the same. But what is our conclusion? What is our conclusion? When I took reflection of point P along x-axis, I got point P dash whose coordinate is 3, minus 2. What did we learn? The x coordinate remains the same, but the y coordinate changes. 3, 3, but 2 turns to be minus 2. 2 turns to be minus 2. So now it's the time to understand this is my x, which is the same, but my y is no longer y, it has turned to be minus y. First conclusion, first point, don't look at the later two. First point, reflection of point P, whose coordinates are x, y, in x-axis, or one can say y equals to 0, is P dash, which is x, minus y. In an equation manner, we write down in this way, reflection along x-axis of a particular point is nothing but x, minus y. Reflection of x, y is x, minus y. Once again, when a particular point gets reflected along x-axis, its y coordinate changes, its x coordinate remains the same. That's the central idea. Now when we are done with reflection along x-axis, we start with reflection along y-axis. What if the same point is reflected now along y-axis? Either you say y-axis or you say x equals to 0. Now what is the distance? The distance is from here to here. So if I say it is from Q to P. So the distance of point P from y-axis is distance QP. Its reflection will be P double dash. Reflection of point P along y-axis or x equals to 0 will be P double dash. So Q will be P double dash will be the same. So if this is my point, original point P, whose coordinate is 3, 2, on reflection along y-axis or x equals to 0, I get P double dash. When I try to plot it, what do I get it? I do get the coordinates as minus 3, 2. So what do I see? My x coordinate changes, but my y coordinate remains the same. My x coordinate does get changed, my y coordinate remains the same. So shall I say it's minus x, y? So the second conclusion, reflection of point P, xy in y-axis, x equals to 0 is P double dash minus x, y. Mathematically written as reflection along y-axis of a particular point xy is minus x, y. Let's summarize the last 2.5, 3 minute session. If there is a point and its reflection takes place along x-axis, y coordinate changes. If there is a point whose reflection has to take place along y-axis, x coordinate changes for a particular point. Now what is the third one? We are done with x-axis, we are done with y-axis. What if we have reflection of this particular point along origin, mean to say origin O, whose coordinates are 0, 0. Now we are going to take reflection of point P along origin. And when I say original, that means I am taking this in a right angle triangle, I am taking this hypotenuse, O to P. The reflection of point P, on the other hand, this is the first quadrant, its reflection will be in the third quadrant. So if the point P were to have coordinates 3, 2, its reflection is going to be minus 3, minus 2. It is this distance, the hypotenuse will be the same. It is this distance O to P, and O to P triple dash will be the same. What did we learn from this? What did we learn from this? We learned that the x coordinate also got changed, the y coordinate also got changed. So what is the conclusion? Reflection of point P, x comma y in origin is P triple dash minus x minus y. So you can say this is nothing but minus x minus y. Mathematically written as reflection along origin xy is nothing but minus x comma minus y. Children, this is what you have to learn. Reflection along x-axis, y coordinate changes, x coordinate remains same. Reflection along y-axis, x coordinate changes, y remains same. Reflection along origin, both changes. Right? We need to know more multiple reflection for a particular point. That is what we are going to see next. But before going further, see to it that this much is what I should know. Then and then only I can proceed further with my chapter reflection. Kindly go through.